Okay, right. So what's going on? So journalists wrote about this. This has been sort of repeated. I'll come back to this one a little bit later on. This is a book that appeared around 2000, and it's going to be based on this theory that I'll talk about later on. And I know I'm just enjoying myself here. That comes around. So no one really figures out anything until just before 2000, right? So there's a paper in Science in 1997, and that will be something we'll get to. That's covered in this book. John Whitfield was a writer for Nature. And he talks about it in sort of glowing terms, Kleiber and all this. Right, everyone loves the elephant mouse thing. This is sort of fun. So we're gonna. We have some work, but there's an explosion of work around this. But I'm gonna point to a couple of things. But I'll show you much other stuff. Anyway, we got ourselves involved because of this network stuff. Dan Rothman is my advisor, who's at MIT. Still, he's in earth sciences there. He's an applied mathematician kind of guy. He's done some really cool things over the last 20 years with the carbon cycle and how life, actually just the expansion of life had sort of changed the atmosphere. And he has work now about extinctions, so it's not fun. Like when the next one's coming, like how things are working statistically, really detailed, deep work. And Josh Weitz is went from physics to biology. He's at Georgia Tech, super guy. Yeah. Anyway, this really did feel like one of these, it was just an incredible sort of amount of work we had to do to figure out what's going on. So here's some data. This is data from Heusner. So this is a meta study, right? So meta-analysis. So he's gone through a ton of papers. This is a really well done paper. And I want to say some more things about Fred Heusner. So Alfred Heusner, Fred Heusner. So he goes and he does it for birds and mammals. This is for mammals. Puts together this really, really well done paper because at the end it has every reference, it has every data set, and all the numbers are there, right? So it's really great effort. So this is pretty weird. So I remember getting what he kind of did was he claimed that it was really 2/3 and people were making a mess of this. And the story that he had was there was just something weird about these larger mammals and that there were really like two slopes. Like you had to kind of think of these as a different thing. He had a sort of statistical argument analysis that said, you really should discount these. And I'm not going to go into that too much. But the thing is, I remember getting the data because it's just sitting at the back, so I just typed it all in. And we were driving down to the Cape actually, and I've got this like massive Toshiba thing, and I plotted and just did a regression. And the thing is, if you just do a straight up regression, you get 0.668. So this is really weird, right? So I'm like, what is going on? This is so strange. And I'd sort of got, I'd obviously reading this paper, which is talking about it being 2/3. It seemed to be this big rebuttal, kind of piqued my interest. So we're trying to figure out what's going on. And 3/4 is this red line. This is in no way proves or shows that it's one or the other, but it's a weird thing. So how do we get to this, right? So we've talked a lot about the river networks, the branching network stuff. There's a really pivotal character in here, Jeff West, who's a very famous guy. He's a theoretical physicist at Los Alamos, but he ended up working with people at Santa Fe in the Santa Fe Institute. He became the head of that institute. And so his work with a couple of others will be the core theoretical work that. Here's the thing, by that point, 3/4 was just true, and the game was just to prove it. And then you get a physicist who will do that, which is fun. It is, and it's sort of shocking to go back to the data. Like I think I talked about in scaling last semester, there's a quarter power scaling for the number of species as a function of island size, right? And that's this kind of cool, MacArthur, I think, was the paper in the 50s. And it's a quarter power, right? And I've seen papers where they prove it. They just show, they've got a little model, the number of species increases as area size to the power of a quarter, and they make a little sort of charming little model that does that, it gets a quarter exactly, right? And there's some story. But if you go back and look at that data set, it's just a horrible mess, where there's just sort of a line just smashed through the middle of it, and it's just sort of, it kind of goes up, and it's not linear. But the thing is that doesn't get seen, and that gets, and back in the day, it's a little hard, right? Because you had to go to a library, right? You had to actually have access to that book. That's different now. Like the photocopying thing was not fun. It was not, you sort of put it down, put the thing, put it down, and eventually you just give up, right? You don't close it anymore. You just like, it's just like, just like it's terrible. Exercise. Okay, so this one is, and this is birds, right? So this is a really interesting one because with birds, it's like super duper 2/3, right? It's 0.664. There wasn't sort of an extra piece up here. So how did people cope with this, right? This is close to 400 birds. It didn't fit this 3/4 thing because people really believe this by now. They just think this is true, and it's a magical thing about biology that no one understands why, right? No one understands why. That's 1987 that Bennett and Harvey done. So what happens around that time when people start to look at birds is that they break them into perching and non-perching birds. So this is clever, right? So the idea of ostriches are not perching birds, for example. So you have, so then the idea was there were two kinds of birds and they both had a 3/4 exponent. That was the little game. Right, so that's the solve for that one, right? It's total garbage, but So it turns out Heusner and Kleiber were both at Davis, and they're a generation apart. When I was sort of looking at this, Kleiber had passed away by that time, and I managed to actually call and talk with, this is a long time ago. Email existed, of course, but Twitter didn't. And I spoke with Heusner. It was interesting to talk to him. He'd retired by that point and was making pots. That's what he did. He made pots, and he would sell them and stuff, and he lived in Davis, and he was having a good time. They were both from nearby, actually, in France and Germany, and they both ended up at Davis. And they became family friends, actually, right? They would go on family vacations together. And this is, just me talking to him, finding this out. And they were very close friends. But Kleiber's sort of whole career was about this 3/4 thing, and then Heusner, for whatever, he works on this stuff too, and he looks at it and he's like, I don't think it's right, it's no good. Publishes papers and he kind of published some of it after Kleiber passed away. But he told me that Kleiber sort of, at least to him personally said, it's righto, it's sort of a mess, and kind of agree with him and so on. But it's kind of an interesting, sad thing in there, that these two people had this, they got along, actually, they got along. I know that Heusner told me that West came to speak at Davis and was just kind of really abusive to Heusner, which is terrible, West is an interesting character. He's English and has a very deep voice, and that gets you a long way in the world if you want to colonize sciences. Anyway, what can I say? That is my weird heritage, I suppose. But I come from not England, but a part that came from England. So by obligation, I must hate them. All right. So there are lots of good people. It's fine. But it's like you must make jokes about the English, and you're very happy if you beat them in cricket. Any sport, actually, because they invented most of them and then are terrible at them, especially soccer. Anyway, no. So the other thing is, though, no, I've gotten along quite well with West. So that's not the issue. But it is very controversial, though, and it's kind of a weird thing because, and I look at the world of fake news now. You really do have scientists who just stick to it. They just say, no, it's true. It's true. Even though you can mathematically show that their mathematical thing doesn't work, people don't read these things properly. It's really true. There's a lot of stuff where people do not go into the details. It's very painful to do that. And it always gives me such hesitancy about any major, messy scientific thing, But, yeah. Okay, so, looking at this, you're like, this is crazy. What is going on?